Hello, everyone, and welcome to the webinar on variable speed drive for industrial cranes applications. First of all, I would like to thank you very much for investing your time with us today. My name is Suelen Pereira Vieira Valentini, and I work as a sales engineer for low voltage drives and controls. And I'd like to introduce to you the webinar presenter, Aloysio João Correia. Aloysio is one of our sales engineers with more than 50 years of experience with automation products and solutions, and a few of this year working with us abroad. Well, so before we move forward, I'd like to share with you some instructions. To assure a good sound quality, all the microphones will be muted. If you have any questions, we'd love to hear from you. So feel free to type in the questions and answer chat. Our team is going to reply to your question during this presentation. A record version of this webinar will be made available, so you can watch it again later. To do it, just access WAG LinkedIn page and click on Events. There, you will find this webinar, past webinar, and the futures one from all the WAG divisions. Also, you can follow us on LinkedIn and YouTube, so you can receive the latest news about WAG, our products, and different solutions tailored for you. So again, welcome, and now it's time to pass you over to Aloysio. Enjoy it.
Thank you, Suelen, for the introduction. Hello, everyone. Thank you so much for attending this webinar today. And for me, it's a pleasure to be here talking to you about variable speed drives for crane application. And the main purpose of today's webinar is to give you an overview how to size the VSD and use the VEG programming software for crane applications. So let's get started, and I wish you a great webinar. The agenda for today's webinar, we will start with a short introduction about cranes, types of cranes. Then we will explore a little bit more the advantages of using variable speed drives for such applications, how to size the variable speed drives, a suggestion from WAG. Then we will configure the software application for crane, and some success case will be shared with you as well. And then at the end of this webinar, we will open a space for question and answers. So what is an overhead crane? An overhead crane is a type of crane used in factories and industries to lift and handle heavy loads, allowing large equipment to be moved horizontally and vertically. Here I brought to you some pictures just to better illustrate it. What are the main working movements? Horizontal motion. So the crane horizontal motion or load translations consist in moving the load in the horizontal direction by executing commands to forward and reverse the load. The long travel, the cross travel, and the boom rotation, among others, are also horizontal motion. Vertical motion. The crane vertical motion consists in moving the load vertically by executing commands to move it up and down. The load hoisting and its lowering are vertical motion. Types of crane. Monorail cranes. So as you can see, it's a common type of overhead cranes consisting of a single beam with a hoist. Double girder cranes. Double girder cranes will have two bridge beams and the hoist trolley travel on rails, usually attached to the top of the crane girder. Gantry cranes. It's a type of overhead crane with a single or double girder configuration supported by freestanding legs that moves on wheels or along a track or rail system. Semi-gantry cranes, designed with one leg riding on wheels or rails and the other side of the crane riding on runway system connected to a building columns or a side wall of the building structure. Tower cranes, type of tower equipped with a hoist, rope, chains or sheaves, and used mainly to lower, lift, and move heavy or bulk constructions material around. Jib cranes can be defined as a crane that has a mounted arm which is used for lifting, lowering, and moving materials. Which device makes the crane movement? Bridge drive, determined as a horizontal motion. Trolley drive, also horizontal motion. And the hoist, used for lifting or lowering the load, determined as vertical motion. And here, to be honest, is where we need to pay more attention while sizing the VFD. So now we want to show you where mainly we can apply VFD in this application. So the VFD will be applied to run those electrical motors and further to this, contributing to increase the performance of the crane system. Advantages of using variable speed drives. I want to start with easy commissioning thanks to the built-in crane application features. And here it's pretty much important to mention that the software that we will demonstrate today, it has a user-friendly interface and it's free of cost, and you are going to understand that contributes a lot for the operator during the commissioning of the crane. Elimination of electrical line disturbance. Since the VSD can control the motor torque, the starting current of the motor will be reduced as well, which will also eliminating this line disturbance. Elimination of mechanical stress, and here we need to point out that it will have increased crane lifetime. Comfort due to the reduction of mechanical noises and vibrations to the system. Energy saving, again, the VSD can control the motor speed and therefore energy saving will be achieved. System automation, so we have the possibility to integrate the VSD into a communication network, and from there you can have access to status, to control the drive, and so on. Open or closed loop control option, it's possible from the VSD. Here, I want to give special attention to this topic, mechanical brake actuation for smooth operation and optimal safety. As you are aware, every crane application requires a mechanical brake to stop the motor, and the VSD is able to control the braking system of the motor as well, the actuation of this motor, the braking of the motor. Automatic braking close, if the fault is detected. This is another advantage that the VSD can handle as well. So now we are going to enter into some suggestion by WEG in how to size the variable speed drive. Before we enter into this step, I would like to give you some indications that in order to ensure safety in load lift application, electric and mechanical device must be installed outside the VSD for protection against accidental fall of load. Some precautions also is important to be paid attention. As you are aware, cranes, they are usually applications with heavy load characteristics. Therefore, special attention must be paid to their dimensioning. The combination of the motor and the VSD must overcome as well high inertia values when it's required. Usually the duty cycle is heavier than that demanded by standard application, example, pumps, fans, etc. The characteristics of the application, such as ambient temperature and altitude, also need to be considered. And you will find from the product user manual the derating factors when required by the application. So, based on WEG knowledge and experience, we suggest the following procedure for sizing the VSD for vertical and horizontal crane application. Then, if you have any questions about the procedure, please contact your local technical support for further information. Let's start with the vertical motion. So, for light or moderate duty operation, such as installation on maintenance, shops, light assembly operation, testing laboratory, warehouse, etc., especially where the load requests on average less than 50% of rated capacity, the following formula are suggested. So in this case, the VSD rated rev duty current is equal 1.15 multiplied by motor rated current considering the service factor multiplied by power required by the load divided by motor power considering the service factory. For heavy or severe duty operation, such as installation on heavy machines, shops, factories, handling steel, coils, container handling, etc., especially where the loads request on average more than 50% of the rated capacity, the following formula are suggested by WEG. So the VSD rated heavy current is equal at 1.3 multiplied by motor rated current considering the service factor multiplied by power required by the load divided by motor rated power considering the service factory. Here we give you some instructions about the braking resistor, which is a must to crane application. So in this case, for crane in vertical motion, we suggest to size the braking the resistor following this formula. The braking resistor power is equal 0.7 multiplied by power required by load, considering a braking duty cycle of 100%. Now let's talk about crane horizontal motion. For horizontal movement, the loads are considered lighter. Therefore, we recommended to use the VSD current in normal duty regime, and this is the formula that we suggest to use. So the VSD considering rated normal duty current is equal 1 multiplied by motor rated current considering the service factory. And again, in respect to the braking resistor, this is the equation that we suggest to be followed. Braking resistor power equal 0.4 multiplied by power required by the load, considering a braking duty cycle of 50%. So now that we have presented some basic overview about types of crane, advantages of using the variable speed drive, how to size the variable speed drives. We would like to show you how to set the software for cranes applications available for WEG inverters. So let's get the software. This is the logo for WEG WLP, which means WEG Ladder Programming Software. And we are going to start from the tools bar. You will find here a section called Applications. You'll see that this application is available for different products from WEG, but today we are going to focus on CFW 500 series, which is a general purpose inverter from WEG available up to 120 kilowatt. Then you go into Create. You are going to see that the wizard for Pump Genius multi-pump is also available for this inverter, but the main focus today is to talk about crane. And again, from here, you will find two options. So you have the wizard already developed for horizontal motion and vertical motion. Today, we are going to demonstrate the vertical motion, which is the most complex movement of a crane. First of all, you have to create a name for this project. In this case, I would just name it as Crane Webinar 1. So the equipment is already selected, the firmware version of this software. So this is the minimum firmware version required for the drive. Here, the software will give the information that the latest version of the WLP software will be considered. And from this moment, I have access to the ladder of the crane application. So now we are able to download this to the drive. In this moment, I don't have a drive connected, but you should do that to transfer the ladder to the drive. And once this step is done, we will start doing the wizard configuration for crane vertical motion. From now on, we are going to have 17 steps where we will be configuring the parameters for crane application. But before we enter to this procedure, I want to give you a special note that we must do the standard startup procedure of the drive. So before you starting transferring the crane application to the drive, we must do the orientate startup the inverter, where you are going to enter into the inverter the motor data, the power supply data. This is standard configuration. Once this step is concluded, then we can transfer the crane software to the standard inverter, and then you will get all the crane functionality into that drive. As you can see here, the software will give us the option for sensorless vector control and vector control with encoder. So for crane application, vector control is demanded. In some case, encoder is considered, but we see most of the time in the industry utilizing without encoder. So sensorless vector control, okay? From step number 2, now, here we are going to start defining the origin of the commands that will select between the local situation and remote situation of the drive. So as you can see, the software already gives you some standard configuration, but you can also change this as per application needs. Step number 3, we will configure the acceleration amps for acceleration times, deceleration, and so on. The software gives you 3 seconds for acceleration and 2 seconds for deceleration, but you can also change it during the commissioning of the crane. Now we are going to set the speed limits for minimal speed and maximum speed of the inverter. Here we are going to determine the speed reference control configuration. So from where the speed reference are coming from. In this case, we set as standard 2 speed reference that we can see most of the time considering the industry, But also you have other option here. For example, you can also select the speed reference coming via a communication network. But we are considering two speed reference via digital input 4. Here you can set if any limit switch is available, for example, or any sensor is available in the crane. So you can set this information come through a digital input 3 or 7. But in this case, we are considering that without limit switch. Now we are able to start doing the digital input configuration. So these are basic commands. For example, digital 1 now is set as load hoisting. Digital 2 is now setting as load lowering, but you can also change this as per your convenience. The same, we do that for the digital output functionality. For example, digital output 1 is set as brake release. We recommend to use this based on our experience as well. And the other output functions is available here to be changed as per convenience. Here we are going to configure the two speed, the two different speed, because in the previous steps we configured that the speed reference will be two speeds. So in this case, we are configuring what's going to be speed number 1 and speed number 2. So you can set those parameters as well. You have the option to set as well a lightweight detection. So for example, if depending on the weight of the load, you can set some parameter here. You can enable this function and the drive will work accordingly. Here is one very important point, which is about the brake release. Because as we mentioned, one of the main functions of this software is to control the braking release actuation of the motor. So you are going to set these parameters here, and the VSD will be in charge to give the actuation for the braking release system. The same for the braking close can be configured, and it will be done via the VSD. Now also we can set some parameters related to overweight detection at load hoisting. So you can configure here the minimal values of current, for example, in order to detect an overload during the hoisting movement. Slack cable detection at load lowering as well can be set from the software. Inverter in torque limit detection at load hoisting and lowering, there is a possibility to set this value from the inverter as well. And as you can see, in the software always will come the block diagram to help you to doing this set. And all this information that I mentioned to you here are clearly mentioned in the user manual. So there is a user manual for the crane application where we will give you full details of each parameter in order to study this later if required. Improper operation fault. So here we can set some values as minimal fault values. So for example, I have set here 3 alarms, and then after 3 alarms, the fault of the inverter will appear. So you can preset some minimal values for alarm before getting a fault of the inverter. Now we are getting to the end of the setup. Here you will set up the main display monitoring, which will be available from the inverter HMI, and you can set this as per your convenience as well. Then you move forward. At the end, you will get a list of the parameters that it was considered for this wizard. You can also print this material and use as per your convenience. After that, we are able to conclude the wizard, and in here you are able to transfer the complete wizard to the VSD. In this case, the drive is not connected, but you have to print to press yes. Also, what we have created in order to support the operator during the commissioning, There are some tables here. So for example, the operator can check, he can operate the load hoisting movement, load lowering movement. He can double check the motor current, motor frequency, and some other parameters. So usually during the commission, we keep this open, and then we can do some tests as well. Also, we have here a table where we can see the alarm conditions, what's happening with the crane during the commissioning as well. We have the states for the digital inputs, the output. We can see it from the software. We have some very interesting tools here for trends as well, where you can monitor online what's going on with the drive. So for example, you can see the DC link levels, reference after the ramp, the starting command. So these trends helps and supports a lot the operator during the commissioning. Okay, so that's a short overview about the WLP software for crane application. And now I also would like to share with you some success case. But before, it's important to mention that this WLP software, it's free of cost to be downloaded from WEG website. As you can see, the interface of using this, it's user-friendly. And most important, this software is free of cost, okay? And as you could see, the VSD ladder programming is carried out directly within the drive in its soft PLC feature. So it's important to mention that WEG VSD has a soft PLC feature, which basically is a PLC internal to the drive. And for that reason, it's not required to have, for example, an external PLC to configure the crane application. You can do that directly through the soft PLC. As we mentioned as well, there is the application manual for the crane vertical motion, crane horizontal motion as well. So all the steps that we have mentioned and showed to you in how to configure the crane application software will be available from these manuals. And from there, you will get a complete description of each parameter and how you can set if any additional information is required. These are some cases of success, just for information and curiosity. Inside the WEG manufacturing plant in Brazil, Jaraguá do Sul, there are around 320 overcrane cranes. The highest overhead cranes has 16 meters. The widest overhead crane has 28 meters. The deepest overcrane has 208 meters. And the highest load in the plant nowadays is 100 ton. And it's important to mention that WEG has 36 other factories around that have WEG VSD on their site, and we are using these overcrane applications as well. Here we have an example in the steel industry. This is a 300 ton overhead cranes where we supplied motors, drives for this application. This is another steel industry application where 5 tons overhead crane. Here we supplied the drives for transaction, for the trawler, for the hoist, and CFW 511 series has been offered as well. Another steel industry, an overhead crane about 10 tons, CFW 11, it was considered in this case. Here we have a rotary winch with a capacity of 50 tons. CFW 11 also was being considered for this application. So this is what I would like to show and share with you about variable speed drives for crane application. I hope you enjoyed it. And now we're going to open a space for questions and answer. And I hope we can clarify all your questions. So thank you so much for attending this webinar today, and see you later.